A wavelength of light that shouldn't be missing, a chemical fingerprint that matches nothing in any scientific database on Earth, a signal detected by two separate instruments on two completely different worlds, separated by over 1 billion miles of empty space, and somehow identical on both. And when the scientist who found it first tried to explain what he was looking at, all he could say was this: "We cannot say what it is." That is not a line from a science fiction script. That is a direct quote from a planetary scientist at the Paris Observatory, describing a real discovery made by the James Webb Space Telescope on the actual icy surface of Pluto. Before we get into how strange this actually gets, here's why you should trust that this is real and not internet speculation. The discovery comes from Bruno Bézard, a planetary scientist at the Paris Observatory, working alongside his colleague Emmanuel Lelouch, also of the Paris Observatory. Their findings have been accepted for publication in the peer-reviewed journal Astronomy and Astrophysics, and confirmed independently through reporting from Space.com and Live Science. This isn't a leaked photo or a form theory. This is data collected by NASA's James Webb Space Telescope, using two of its most sensitive instruments analyzed by working astronomers, and headed for formal publication in one of the field's respected journals. Here's the simplest way to understand what these scientists are actually doing when they study light from a place nobody has ever physically visited. Every chemical compound in the universe absorbs light in its own unique pattern, almost like a barcode. Point a scanner at a can of soup in a grocery store, and the machine reads the specific pattern of black and white lines to tell you exactly what's inside without ever opening the can. Webb does something almost identical, except instead of a barcode scanner, it uses an instrument that reads incoming infrared light from a planet's surface. And instead of a soup can, it's reading the surface of worlds billions of miles away. When light hits a particular molecule, that molecule absorbs specific wavelengths and lets others pass through, leaving a gap in the spectrum that scientists can trace back to exactly what substance produced it. Every molecule ever cataloged has its own barcode. And in 2026, Webb found a barcode that matched nothing on file. To appreciate how big a claim that actually is, it helps to understand just how thoroughly cataloged planetary chemistry usually is by this point. Scientists have spent decades building up reference libraries of molecular fingerprints, drawn from laboratory experiments here on Earth, from spacecraft flybys, and from earlier generations of space telescopes. Ices, gases, and organic compounds across the solar system have, for the most part, already been matched to known chemical signatures. Finding a gap that nothing in that entire library explains is rare enough on its own. Finding the exact same unexplained gap on two completely unrelated worlds is the kind of thing that makes a working scientist stop everything else they're doing and double-check their instruments. So let's get straight to the moment this all started, because you don't want to wait for this part. Back in November 2022, Bézard was combing through Webb's infrared data on Saturn's giant moon Titan, a world wrapped in a thick, smoggy atmosphere denser than Earth's own, dotted with seas of liquid methane and vast dunes built from organic particles that rain down from its skies. Buried in that data was something odd, a very specific, narrow dip in the light at a wavelength of about 5.113 micrometers. Bézard checked it against every molecular fingerprint on record. Nothing matched. Not water ice. Not any of Titan's known organic compounds. Nothing in the standard catalog explained it. Here's a fast recap before we go further, because the next part builds directly on this. A telescope built to study galaxies at the edge of the observable universe just found something in our own solar system that doesn't match any known molecule. One scientist, one moon. One completely unidentified signal. And instead of shelving it as noise, Bézard did something that ended up cracking the case wide open. He wondered if it might also exist somewhere else entirely. He reached out to his colleague Emmanuel Lelouch, who had led a separate Webb observing program, one that had pointed the telescope not at Titan, but at Pluto, all the way back in May 2023. Bézard asked him a simple question. Did Pluto's data show the exact same signature at the exact same wavelength? Lelouch checked. It did. The identical unexplained feature at 5.113 micrometers showing up on a completely different world. Now here's the part that should stop you in your tracks, because this is where the mystery stops being a fluke and starts being something scientists have to take seriously. Titan and Pluto are about as different as two solar system objects can be. Titan has a thick, active atmosphere with a surface pressure about 50 times greater than Earth's. Pluto has almost no atmosphere at all, a thin, frigid haze clinging to a surface locked in permanent, brutal cold. One world is geologically alive, carved by rivers and rainfall. The other is a frozen, largely inert outpost at the edge of the solar system. And yet, on both of them, at exactly the same point on the infrared spectrum, something is absorbing light in a way that no known compound in any laboratory on Earth has ever been recorded doing. To rule out the most obvious explanation, that this was simply a glitch in the telescope itself, the team checked whether the signal showed up in only one instrument. It didn't. The exact same absorption feature appeared independently in data from both of Webb's separate instruments, the near-infrared spectrograph and the mid-infrared instrument, which use different detectors and different optical paths to gather their data. When two independent instruments, built by different teams, both catch the same unexplained fingerprint, that rules out equipment error and leaves only one real possibility. Something out there is actually producing this signal. Let's pause again, because this is worth sitting with for a second. This isn't a case of a strange blip that vanished under a second look. This is a signal that has now been confirmed twice on two different worlds using two different pieces of equipment, and it still doesn't match anything cataloged in modern chemistry. In the next part of this, we get into where scientists think this mystery compound is actually coming from, and why it might be quietly falling out of the sky on both of these worlds like snow. If a discovery like this, something Webb wasn't even built to look for, hiding in plain sight on two worlds at once, is the kind of story that gets your attention, this is a good moment to hit subscribe, because the explanation the team landed on is even stranger than the discovery itself. Bézard and Lelouch's working theory centers on photochemistry, a process where ultraviolet sunlight tears apart simple molecules high in a planet's atmosphere, and the resulting fragments recombine into far more complex compounds. Both Titan and Pluto share atmospheres built primarily from nitrogen and methane. When sunlight strikes those upper atmospheric layers, it doesn't just illuminate them, it breaks them apart into highly reactive chemical fragments, which then reassemble into new, more complicated organic molecules. Some of those molecules eventually condense and snow gently back down onto the surface below, exactly where Webb detected the mystery signature. The team found supporting evidence for that theory in an unexpected place, the geometry of the signal itself. As Webb scanned across Titan's disk, from its center toward its outer edge, the mystery signal steadily grew weaker. That's exactly the pattern you'd expect if the signal were coming from the solid surface rather than the atmosphere above it. Because light reflecting off a flat surface looks strongest when you're staring straight down at it, and weaker near the edges, where your line of sight has to pass through more atmosphere at a steeper angle. When the team checked a known atmospheric gas, carbon monoxide, as a control, its signal stayed essentially constant from center to edge. It didn't fade the same way. That contrast helped confirm the mystery compound wasn't floating in the air. It was sitting on the ground. Pluto offered its own independent proof. Pluto's atmosphere is so thin, so close to a vacuum, that it is physically incapable of producing an absorption signal as strong as the one Webb detected. If the compound were in Pluto's air, the signal simply couldn't be that deep, which meant, once again, the only real source left was Pluto's solid, icy surface. Two completely different worlds, two completely different lines of evidence, and both pointing to the exact same conclusion. Whatever this is, it isn't floating. It's frozen into the ground. And then the team ran one more test, a kind of control group for an entire planet. They checked Webb's data on Ganymede, Jupiter's largest moon, a world that has no nitrogen-methane atmosphere at all, and therefore can't run the same photochemical reaction Titan and Pluto both rely on. If this compound had nothing to do with nitrogen and methane chemistry, it should show up on Ganymede too. It didn't, not a trace. That absence was almost as important as the discovery itself, because it tied the mystery molecule directly and specifically to worlds that share this particular kind of atmospheric chemistry. So what actually is this compound? The leading candidate right now is a family of hydrocarbons called alananes, which are, according to the study, essentially the only class of organic compounds known to produce strong absorption in this exact part of the infrared spectrum. But there's a catch. Scientists only have complete reference spectra for the simplest alene molecules. The more complex variants within that same chemical family remain unmeasured in any laboratory, meaning it's entirely possible the signal comes from one of these unstudied cousins, or even from several of them layered together, blending into a single unfamiliar signature. There's also a second possibility the team hasn't ruled out, that the signal actually belongs to a molecule scientists already know well, but whose spectral fingerprint has been subtly altered because it's mixed together with other planetary ices that haven't yet been fully mapped in combination. Chemistry on Earth rarely has to account for compounds freezing and blending together at temperatures this extreme, which means some familiar molecules may simply behave in unfamiliar ways once they're locked into ice this cold. Now, to be clear about what this discovery is not, because this is the point where a story like this can easily get overhyped. There is no evidence that this mystery molecule is a biosignature, and Bézard has been explicit about that. This is not a sign of life, and nobody on the research team is suggesting otherwise. What it most likely represents is the kind of complex, non-biological, prebiotic chemistry that has been quietly running in Titan's oxygen-free skies for more than 4 billion years. chemistry that produces increasingly complicated organic molecules without any living thing involved at all. It's also worth being honest that identifying the exact compound could take years. Confirming its identity may ultimately require matching it against laboratory-grown samples of increasingly complex AL invariants, a slow, careful process of elimination rather than a single dramatic reveal. There is one more piece of this story still unfolding, and it stretches nearly a decade into the future. NASA's Dragonfly mission, a car-sized nuclear-powered rotorcraft, is scheduled to launch toward Titan in 2028 and arrive in the mid-2030s. Dragonfly won't carry an infrared spectrometer like Webb's, so it can't repeat this exact measurement. But it will carry a mass spectrometer capable of directly sampling and identifying organic molecules across Titan's surface, essentially tasting the ground at multiple sites across the moon. If Dragonfly manages to detect a compound that matches the profile of this mystery signature, it could hand scientists back on Earth an actual physical sample's worth of clues, something to finally test and confirm in a lab, nearly a decade after Webb first caught the signal that started this entire investigation. And that is really the story here. Not a confirmed answer, but an open question, sitting quietly on the frozen surface of two of the strangest worlds in our solar system, waiting for a rotorcraft that hasn't even launched yet to bring back the evidence that might finally solve it. For now, the closest thing to an answer anyone has is an honest shrug from the person who found it. Bézard summed up his own reaction to it simply enough. "It's always exciting," he said, "to discover something that was not seen before. It's really the nicest part of the job. So tell me in the comments, do you think this turns out to be some undiscovered variant of AL in hiding in plain sight? Or do you think Dragonfly is going to land on Titan in the 2030s and find something nobody on that research team ever expected?